Let us talk about this question. Yesterday we talked about contract curve. That is the set of Pareto efficient allocations. Now let us try to find out the equation of a contract curve, right? So we have initially there are two individuals. I'm individual 1 A and you guys are individual B. And this is the endowment, my endowment 0 10, and this is your endowment 10 0, right? So this is the case of squared Edgeworth box, right? And here, because why do I say that this is case of squared edged box? Because the total amount of x available in the economy is 10 and the total amount of y available in the economy is also 10, right? So that is the reason it is a squared Edgeworth box. And then you have a rectangular Edgeworth box here. So total amount of x available in the economy is 15 and the total amount of y available in the economy is 10, right? Again, this guy is a squared Edgeworth box. Also, this is the case, this one, where my utility and your utility, they're both differentiable. They're strictly convex, right? So strictly convex, right? And when you have preferences, they are not strictly convex. This is that case where you have min of xa y, not strictly convex, right? So we're going to look at these cases today. Let's look at the first case. So we have UA is equal to XA by A, UB is equal to XB by B, EA is 0 10 and EB is 10 0. That's a question. Yeah, that's a question. Let me just draw the Edgeworth box. This looks like a squared Edgeworth box here. So the total amount of X in the economy, total amount of Y in the economy, right? Total amount of X in the economy and total amount of Y in the economy, right? So I'll just give you few points here and there. So for example, is this point Pareto efficient, alpha, let us say? Is this point Pareto efficient or not? Well, the utility which is passing, my utility which is passing through alpha is this, and your utility which is passing through alpha is this, right? There is a lot of intersection of our better off regions. So I'm not repeating the stuff which I have done yesterday. I'm not repeating that stuff again. That is, yes, there is a lot of intersection of our better off regions. And so those of you who have not seen the earlier recording, please see to that, where we have talked about how do you find out a weakly preferred region for individual 1 and weakly preferred region for individual 2. And if you're able to find out the intersection of these weakly preferred regions, that would mean that yes, there is a possibility that both of us can increase our utility, or at least one of us can increase our utility without decreasing the utility of the other individual. So in this case, let's say if we move from alpha to this point beta, right? This point beta. So what happens is that your utility is kept constant, but my utility increases, right? So alpha is not Pareto efficient because beta is what we have found out this as a Pareto superior point to alpha, right? And from beta, if you move anywhere, for example, you move here, you move here. So for example, if you move here, for moving here, My utility is kept constant, but your utility falls. So you move on to the lower indifference curve. You move on to the lower indifference curve. And if you just carry it on, so beta is going to be Pareto efficient because you cannot increase the utility of one individual without increasing the utility of the other individual. So you have these points as mm, hmm, these points as the Pareto efficient points. These points as the Pareto efficient points. And I hope you remember. I mean, in case if you're saying beta is the point which is Pareto efficient, so it means the slope of these two indifference curves, that is my indifference curve and your indifference curve, is same out here. So they're tangent to each other. We've also derived the condition yesterday, if you remember. MRSXY A is equal to MRSXY B. For a strictly convex and differentiable functions, you can use this. So MRS XYA is equal to MRS XYB, right? So you have what? Your del UA by del XA upon del UA by del YA, that is what MRS XY for individual A, del UB by del XB upon del UB by del YB. So what is del UA by del XA? Del UA by del XA is just YA. Del UB, del UA by del YA is what? Just XA. Del UB by del XB is what? YB. And del UB by del YB is what? XB, right? But you should know of one more thing. That is amount of X which I have plus amount of X which you will demand should be equal to, the amount of X which I'm going to demand plus amount of X which you're going to demand should be equal to the total supply of X. Total supply of X is amount of X which I have is 0. Amount of X which you have is 10. So it is 0 plus 10. That is 10. So the idea is that I can write XB as 10 minus XA, right? Similarly, amount of Y which I'm going to demand, amount of Y which you're going to demand should be equal to the total supply of Y. So the amount of Y which I have, which I'm endowed with, is 10, and the amount of Y which you are endowed with is 0. So it is 10 plus 0. That is 10. So you can write YB as 10 minus Y. So you have what? YA by XA is equal to, in place of YB, you guys can write 10 minus YA all upon 10 minus XA. I hope I've done this right. And when you will just multiply this, you'll be getting 10 YA minus YAXA, YAXA is equal to 10XA minus YAXA. Avada. So you have what? This YAXA will get cancelled out. This 10 will get cancelled out. So this guy becomes the equation of the contract curve. XA equals to Y. This guy is going to become the equation of the contract curve. XA equals to Y. Okay. Meanwhile, you can find out the contract curve for the subcase 2, where the endowments are changed. That's the only thing, is that endowments are changed. So it is 0, 10 and 15, 0 out here. 0, 10 and 15, 0 out here. So can I just do the changes here? Because everything else is same. You and I have same amount, same way our utilities are going to be drawn. But the only thing is that our contract curve, sorry, our endowments are different, right? Our endowments are different. So you have what? Your in the second sub case, beta, in the second sub case, you have XA plus XB is equal to the total supply of Xn. This is what 0, 10, 15, 0. Let me write it. So EA is 0, 10 and EB is 15, 0. Mhm. So the total amount of X is, I have 0x and you have 15x. So it is 15. So XB is what? 15 minus XA. Total amount of Y, the amount of Y which I'm going to consume plus amount of Y which you're going to consume should be equal to the total Y which is available, which is 10. So that is, amount of Y which I have is 10, amount of Y which you have is 0. So it is 10 plus 0 is this. So YB is equal to 10 minus YA. YB is equal to 10 minus YA. The condition is same, beta. I hope you know this condition. This condition is same. So it is still your MRS XY A is equal to MRS XY B. And you have the same thing, del UA by del XA upon del UA by del YA equals to del UB by del XB upon del UB by del YB. And you will be getting this condition. So YA by XA equals to YB by XB. You will be getting this condition. I'm sure that all of you can get this. And in place of YB, I can write 10 minus YA. And in place of XB, I can write 15 minus XA. So you have what? 15 YA minus XAYA is equal to 10 XA minus XAYA. So this XAYA will get cancelled out, and you have what? You have then 3YA is equal to 2XA, right? So you guys can write XA is equal to 3 by 2YA. XA is equal to 3 by 2YA. That becomes your equation of the contract curve in this case, right? Equation of the contract curve in this case. So in case of a squared Edgeworth box, you have XA equals to Y, right? So the equation looks like this. So this is 10, 10. And this is origin of A, this is origin of B. So your XA is increasing in this direction, YA is increasing in this direction. So if you want to put XA equals to YA, so that line would be this guy, just a line like this. This is what your XA equals to YA looks like. This is what your XA equals to YA looks like. This is what your XA equals to YA line looks like for a squared Edgeworth box. XA equals to Y. If you have rectangular Edgeworth box, then what happens? You have XA is 15, right? And YA is 10, let's say. So XA is 15, YA is 10, like this. Okay. Acha, don't draw this, but just think about it. In case if XA equals to YA would have been here, then in case if this kind of line would have been there, xa equals to y, although you have xa is equal to 1.5y, but if xa equals to y would have been here, how would you have drawn this? 0 0 1 1 2 2 3 3 4 4 10 10 यही होता ना, this would have been the case. So this is not this line, right? I'm just telling you how xa equals to ya would have looked like in this case. This is what your xa equals to ya line would have looked like, right? So xa 10 ya 10, something like this. Acha, what about this? xa is equal to 3 by 2 ya, or ya equals to 2 by 3 xa, or ya equals to 2 by 3 xa. You could have done this. Fair enough. So is this passing through origin? Yes, it is. Xa is 0, y is also 0. So it is definitely passing through origin. Okay, what is the maximum x which you have? 15. So y in this case comes out to be 10. So when xa is 15, y is 10. One thing is that. Amita, when xa is 15, ya is 10. So this guy, this is the way your equation of contract curve will look like in this case. So ya is equal to 2 by 3 xa. This is the equation of the contract curve, and this is the way you will draw this, right? Okay. What about the third case? So min of xy and xp yp, and think 0 10 10 0. Okay, yeah. Squared Edgeworth box. Let's look at that. ub is equal to xp yp. So I am a min person, min of xy, and you guys are Cobb Douglas. You guys are Cobb Douglas. So let me just draw the Edgeworth box first. Right? Okay. This is my origin, beta. This is your origin. Acha, there is a rule. Whenever you have a kinky function, you will draw the kings first. You will draw the kings first. Where are the kings here? xb equals to yb. These are the kings. These are the kings. So you will draw the kings first. So uh, first of all, it should be xay. Sorry. Amata. You will draw the kings first. So the total amount of x in the economy is 10. 0 plus 10. Total amount of y in the economy is 10. 10 plus 0. Right. So xa equals to ya line is this. यही होगी ना? xa equals to 1, ya equals to 1, xa equals to 2, ya equals to 2, xa equals to 10, ya equals to 10. That's it. So this is not the contract curve. We have not said anything about it yet, but this is what your uh, kink line is looking like. Fair enough. What about an indifference curve which is passing through this point? Let's say like this. So my indifference curve passing through this is this. I am a min function now. Your indifference curve passing through this is this. Avita, your indifference curve passing through this is this. I'm sure that you know that my utility is increasing in this direction and your utility is increasing in this direction. Fair enough? Okay. Then what happens? Fair enough. Uh, can you just also imagine, before I point out this particular point, can you imagine what about this point, alpha? My indifference curve passing through alpha is going to be this only, which is a kink at beta. Beta, kinks are predefined. It is not that you can draw, for example, my indifference curve passing through A would be like this. No, wherever the point is in, I'm drawing the kink. No, that's not there. Kinks are predefined. Kinks can only be at this point according to the kink key function which I have. So my indifference curve passing through alpha is this, which is a kink at beta, and your indifference curve passing through alpha is this. Now you tell me, is alpha Pareto efficient? No, it is not. Because if you move from alpha to beta, what happens? I remain on the same indifference curve, but your utility increases. You move on to the higher indifference curve. That's right now, because your utility is increasing in this direction. So you move on to the higher indifference curve. My utility is same. From alpha to beta, my utility is same, but your utility increases. So it means what? I've been able to increase the utility of one individual without decreasing the utility of the other. So alpha is not Pareto efficient because you are able to find out beta, which is a Pareto superior point to alpha. You just need to scan the entire Edgeworth box to find out whether you can find out a Pareto superior point or not, right? That's it. So if you're able to find out a Pareto superior point, then the reference point is not Pareto efficient. So what do you have? Alpha is not Pareto efficient. What about beta? Hmm? What about beta? Is beta Pareto efficient? Yes, it is. Why? Because if you look at the better off region, for me, my better off region is this beta. Mhm. Your better off region is this guy. Is there any intersection of our better off regions? No. So if there is no intersection of our better off region, it means that all gains from the trade are exhausted at this point. You cannot make one person better off without making other person worse off. So if you move from beta to anywhere, for example, if you move from beta to, let's say, point this A, you will not have a problem. You are on the same indifference curve. Why will I move? Because my indifference curve passing through A would be this now. Hello. My indifference curve passing through A would be this, which is a kink at B. That's a lower indifference curve as compared to the indifference curve, which is a kink at beta. Right? So I will not move. Why will I ever move to a inferior point? That's completely out of the question. So it means that beta is Pareto efficient. You cannot have you all the gains of trade are exhausted at the kinks, right? And you have also seen that other points, apart from these kinks, other points are not Pareto efficient because you can find out a Pareto superior point. For example, if you move from A to beta, let's say, then what happens? You remain on the same indifference curve, but I move on to the higher indifference curve, right? So beta is Pareto superior to A. A is not Pareto efficient. So any point which is not on this kink line, you can find out a Pareto superior point. And hence you can say that this line itself is a Pareto, is a set of Pareto efficient point. So in this case, you can say the contract curve is what, right? Xa equals to y. Contract curve is what, which is Xa equals to y, right? So the idea is that that you can't just use the tangency condition out here, because for non-convex preferences you cannot use tangency condition, and particularly here it is not even differentiable, so you can't use that. So you'll have to use logic in order to get through these problems. Huh? So I hope this video would have helped you in some way. Huh? Thank you, beta.